Test. Yes, can you hear me?
Yeah.
I can hear you also.
Give me a second.
Sure.
I guess I'll give an update on certain things up.
Yes, that would be nice. Yeah.
So yesterday we finished up probability tutorial for math.
Okay, right.
So yeah, we'll be going into, but there's like no more math tutorials this week. So we'll only be going into distinct random variables tutorial by next week.
Right. Okay. Has your lecture go beyond DRV?
Yeah, lecture we're at binomial now. We reached binomial yesterday. And are we gonna continue to sorry.
Right.
I don't think we are. No, we'll continue binomial on Thursday.
Okay.
And then for physics, we finished superposition tutorial, and we're going to quantum physics.
Wait. Sorry. You mean wait. Your physics tutorial means you covered the single slit and the grating.
Yeah.
Huh? Okay. Right.
Yeah.
Okay. Then. Okay.
And then yeah, so we did that today. And we are going. Yeah, we did it today, and then after that, yeah, we did it today, and then we're going to quantum physics next week.
Okay.
Chem. There's no. Was that chem? Just check. Chem. No, chem first. Chem first lesson. First lesson of it is tomorrow. Yeah.
Okay.
That's about it.
So you finished your tutorial class for the slits are done lah, but never mind. Just feel that we did cover. Yeah.
Obviously, I have to. I still have to do more. Because I kind of rushed to the end because I need to catch up with the class. So I think when I go through some of the assignment questions, I'll definitely help for like. Because after the end of the tutorial, there's assignment question. So I'm not confident I can like do that myself.
Right. That's what I feel like. I don't think we have covered enough lah. So the questions from your assignment, you'll probably have it on the next coming Sunday lah. Something like that.
Yeah, most likely.
Okay, so that's great. Yeah. Okay, so thanks for the update. Now for today, what do we do?
I hope more chem because I knew prep chem. It's another elucidation question, but I did a lot of the
yeah. So let's see whether you have digested everything and do everything else. So I'm just gonna read what you. This is the question, right? Okay. So we're using have I told you starting today this week we'll just use the same Jamboard for the whole week, yeah. So sure. I'm gonna put this on the same thing on page 3, right? Okay. So right. Did you try? No. This one first. Never. Okay. Yeah. So nice. Distill. Yeah, nice. Yeah. Okay. Right. Right. Okay. Nice. The D did not react either with warm acidified blah 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 or with aqueous bromine. You didn't write any. Oh no, you did write the no double bond, right? Okay. Yeah. So the did not react with either warm acidified potassium dichromate. I feel you didn't write enough. I feel. Yeah. So the aqueous bromine no double bond, but no oxidation, that's not good enough for potassium dichromate. You will say probably that.
They're not.
Come on, you. Oh, come on! Like you're asking me, and I'm telling you the same thing as I told you last few questions.
I already put the aldehyde or ketone, right? So
right. Okay. Right here. What?
As far as I know, I can only reduce aldehyde or ketone.
Yeah, for example, the fact that D did not react with acidified potassium dichromate, right? Warm, means that it is not a ketone.
Did not react, not a ketone. But I thought ketone.
Yeah. Did I get it correct? Yeah. Sorry, please check it.
Oxidation of aldehydes only.
Yeah.
Okay.
Wait, for the K2CR2O7.
Oh, that means they are ketones. Like D is a ketone.
D is a what? Sorry. Well.
Aldehydes can react with K2CR2O7.
Yeah, correct. Yeah,
And
sorry,
other
yeah, I say it wrongly. Yeah, I say it wrongly. That means that it is now a ketone. It is now a ketone. So because either ketone or tertiary alcohol, either one, right? Ketone or tertiary alcohol, and that is what I want you to write. And I feel that you didn't write that. I feel that you should be writing that. I feel that that's really all right.
Can tertiary alcohols be reduced?
That's a question for the next sentence lah. For this sentence, that for the did not react with either, that you could have concluded that it is a ketone or tertiary, and then the reduction will now narrow it down to ketone.
Okay. Fair.
Right. Yeah. Right. So yeah. So I feel that's what is missing. I feel that you didn't translate that. The meaning is not no oxidation. That's not what they're trying to tell you. Of course, there is no oxidation, but that's not what they're trying to tell you. Understand it?
That means I'll just have to create isomeric ketones.
I think so, and not gonna be very difficult. Two isomers, equivalent mixture to isomer with right.
So ketone C. I suppose.
Who are you trying to draw here? Sorry.
I need to draw a alcohol, right? So I need to draw a secondary or primary. Secondary alcohol.
Yeah.
So I assume one is like that, and the other one is propanol. Propanol.
You're missing one H.
Yep. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 9. You got 10. Yeah.
Okay. So you're trying to draw E, is it? I'm guessing lah. Maybe E.
Yeah, no, I'll try to draw F.
Okay. Okay. All right.
So secondary. Now but that's if I put the OH here, there'll be a I can't really use this because I put it here just to be the same one. So
right.
I was thinking. But this can only, if I put the OH here, it'll be a tertiary. I put the OH there, it'll be a primary.
Correct. Must it be a secondary alcohol?
I'm pretty sure ketones reduce the secondary alcohol.
Because that's the reverse. Because that's the reverse of the oxidation.
Yeah. How else can I try? No. Cyclical, no. Cyclical only can make 8 hydrogen. 9, no 8.
Cannot. A cyclical will reduce the number of H by too much lah.
Yeah.
Try considering D first.
D, okay. So it needs to be 4 carbon again.
Consider D from E first lah, right? From E first lah. So I guess that's the easiest way.
So it'll be 1, 2, 3, 4, yeah. 4. And then I think that's 1, 2, 3, 4, 5, 6, 7, 10.
Yeah.
Okay, all 4 bonds, yeah.
Yeah, so again, just checking that the reduction reaction that you're referring to directly attacks the CO double bond. Just checking. If they explain that, if they don't, then that's fine.
Yeah.
Right. Clear, yeah. So the product from D must be E lah, confirm lah. I mean simple lah, simple as that lah.
But then how does it?
Correct, because if D is like that and E is like that, then currently I don't see any way to become an isomer lah. I don't see it. And a C4 doesn't leave much for of a so the issue, my issue first thing was that D gave a pale yellow precipitate. That bothers me a lot, right? Because that again how you read it, I don't like it. I don't like it at all, because it's not that it's having a CH3. That's wrong. It's having a CH3 next to, oh my goodness, you're reading. So the
that was next to OH.
Next to, no, they're next to two things, either the OH or something else. You should know that this test is in hydroxy and carbonate. We talk about this.
Yeah, next to the O as well.
Next to the CO, you mean?
CO.
Yeah, next to the CO lah. So either next to an OH, COH lah, or a CO lo.
Let me make that clear.
So at least it makes sense with your, I think it makes sense to your D right now, because you do have a CH3 next to your CO. And of course, the fact that it reacts with that means it's a carbonyl. We are still not double ketone. No, it doesn't. Double ketone. No. If it is a double ketone, do we have a isomer? No. Yes, no. The problem is, if we have a double ketone, we must have a double alcohol, so we cannot have that. No, we cannot. We cannot. Yeah. Right. So without wasting too much time, this is as far as we can go right now. Huh? Now, what is the new thing that we discussed? There is 15 minutes. What is the new thing we discussed that you didn't think about, beforehand?
Probably this one. Ketone or tertiary alcohol. I don't even consider tertiary.
True. But there's a big but. But you already suspected there is a carbon, right? From the thing, right? And you did say that D might be aldehyde ketone. So my confusion is more like you could have tried to draw some D and some E already at least lah. So why didn't you?
I thought I should leave it to the end when I got all the clues.
Like what do you feel were missing?
What did I feel were missing?
Yeah, you're saying that you want to have all the tools. I mean, it's true that I feel that you're missing something, but it doesn't feel that you miss some. You feel that you're missing something. It feels that you feel that you have read everything. Feels to me.
Sure. I just.
My point is, when you start to draw, you start to think much better. Of course, your reading is great, but once you draw, everything starts to come together. Whether your drawing is right or wrong, you will autocorrect, because that's you. You can do that. Okay, that's all I'm trying to say. I feel that you should have tried drawing it after reading it, of course. True. Read quickly, and then draw. Okay. That's what I
Okay.
feel. So at least you have gotten D and E. Okay, we're very confused with F right now. We'll leave it and maybe we'll get some inspiration later. Okay, now kindly label your E first. Sorry, kindly label the E first. Now, let's say going from D to E. Do you know what kind of reaction is happening? Actually, I don't understand what's the meaning of explaining the reaction. I don't understand.
I assume they want me to explain like what reaction is going on if like they give a positive test, like this is triiodolethane, then this one is reduction with what.
So like the table thingy, the table that your teacher suggested, is it? Something like that?
One.
Oh, so you're just putting it nicely what you already did like in pencil, something like that. They expect you to do that, is it? Okay.
Yeah.
I guess for the marks. Okay, you can do that later then, because obviously you have the most of the answers. Okay. Okay. Now, any other question for chemistry?
No, actually.
Okay. Okay. I would like to encourage you to try to draw after reading.
Yeah. Okay. Let me. There was a physics stuff. I guess I can go into that right now.
Yeah. I feel that we are. Never mind. The lab. I mean, our 3 hours can only fit two subjects anyway. So, so if you have a physics question.
Yeah. Where is it? Okay.
Did you have a chance to ask your teacher about the thing, the curving at the edge?
No.
Please ask. Yeah. Please ask.
Part 3, my teacher can't just left it up there. His explanation was very confusing.
Oh, so you did ask, but you didn't get a clear answer.
Yeah, I was just that's just the way.
Never mind. At least you asked. If you ask, then good lah. Then that is really good for you.
Part 3.
Remember.
I'm not sure how to explain.
Yeah. Okay. Right. I will remember that you don't get a clear answer yet. Okay. Right. Okay. Yeah. So you got the first one, and then you got the second one. Good. This is a white light. So for the maximum angle, you're using a certain color, right? And for the minimum angle, you're using a certain color. Please tell me.
Oh wow! Red is the largest color. Wait.
What do you mean by largest color?
Longest
wavelength. Sorry. They did give you 350 to 650. Sorry. Okay, so for the maximum angle, you use 650, right? And then for the minimum angle, you use 350.
Yeah, that's
right. Okay, great. Good. Now, the second or third order maxima of the white. Yeah, okay. So you already, actually, the part 1 and part 2 is already giving you. I'm not sure what, just going to show you the picture. So, what is the advantage of, can you answer this? What's the advantage of using a grating, which is multiple slit, right? Compared to a double slit? Do you have any idea?
Advantage. I thought it was like splits more.
No. Every what do you mean by splits more? Sorry.
Like sort of like for white light, it's like you get more like I put this. It's like it's more pronounced.
There's more. Yeah. If you're not saying, this is a very nice picture. So your note should be saying that the contrast is there, lah. So meaning to say the bright is very thin, and the dark is in this case quite big, lah, right? Quite big. Now normally you may think that the bright being thin, hey, there's very thin brightness. Doesn't that sound like a bad thing, right? Now, what do you think? Does it sound like a bad thing or a good thing?
I mean, it sounds bad, but I don't. But if I rationalize it, probably not. It's like thin means it's tall, right? That means it's like
no, yeah, it's brighter than double slit. True, you can see the length. Yeah, you can see the length. Right? True. So, what do you think? Again, what do you think? For viewing purposes, because you know that the fringe separation is something that you're trying to measure manually, right? Like really using a ruler or something like that. Really manually.
It's more accurate. It's like you can tell where the center is.
Because it's thinner lah. Where if it's thicker, that is you may miss more lah. And that is truly the aim of diffraction grating. I mean, again, you can see that the fringe separation between double slit and diffraction grating, according to this, is basically exactly the same, right? The position is exactly the same. Correct?
Yeah.
However, it is easier to measure using the results of the diffraction grating. Again, because of the contrast, the bright and the dark are there. So that's the main advantage. So you don't measure white light with double slit, you will get almost nothing because from your calculation, you know that the red and the violet will overlap, right? The waves will overlap. In double slit, it will overlap a lot, so it is very difficult to distinguish between them. Make sense? Am I making any sense? Sorry.
The red and violet.
So again, if you're trying to measure white light, right, you're measuring a lot of color, which is to say you're measuring a lot of wavelength, and therefore they will start to overlap. Now, if you see your Jamboard, you see that the center is white, but that's because the red and the violet is always at the center, so you'll get the white in the center. But starting from the first bright, you will start to see the color separate. The color is separating because they land on slightly different place, right? The red will land slightly further than the violet, so to speak. Again, I hope that makes sense. Huh? Now, if you do this with double slit, imagine that this is the red, right? Imagine that that's the red, and then the blue or the violet will be slightly closer lah, right? But the center will be blue right here. Sorry, the center will be blue, but it will kind of like that, something like that. So closer lah, like that. Then here closer also. In the Jamboard, are we looking at the same Jamboard?
Yeah, it's loading. It's loading around. Yes, that much of a difference.
Yeah. Okay. So now you're seeing the blue and the red in the Jamboard, yes?
Yeah.
Okay. So the blue and the red will be next to each other, but overlapping more compared to if it is a diffraction grating, it will be overlapping less lah, so to speak, less, because they are still next to each other, but they are not overlapping as much, something like that. And that makes it much easier to see that there is red, there is blue, and then to try to measure them all in the same result, so to speak. Okay. Am I making any sense or not? Sorry, please tell me. Please tell me. Right. So the diffraction grating reduces the overlap to make your measurement better. Again, you're doing this manually. You have to identify, okay, roughly here's the blue one, and roughly here's the red one. Okay. Less overlap, easier. Now, I'm giving you many hints to answer part 3. So, the third order spectrum, again, I'm going to use a color for this. So, for the minimum angle of the third order spectrum, so we are referring to what color here?
Minimum, so it's violet.
Right. So, we're talking about the violet's third. So, I'm going to use this picture. Here's your violet first, right? Here is maybe your violet second, I think, and there you go, that's your violet third. There you go, right?
Okay.
And then here's your maximum angle of second. We're talking about what color?
Red, so second red.
So here's my first red, and then here's my second red. I can already not tell clearly whether it's actually overlapping with the violet third. Again, that's expected, right? Because red is further, violet is closer, and you will expect them to overlap one of the order lah, I suppose. Okay. Now in my picture, at least the red is still looking maybe I'm pushing the boundary between red and orange there, right? Okay, a bit difficult to see, right? But the red seems to be at least closer than the third violet, so it's making some sense. Okay, it's at least making some sense. Now you look at the results here. Look at that. The third violet is actually closer to the center than the second red. That's very confusing already. Do you understand what I'm saying? So basically this question is saying that my third violet is before the second red, something like that. That's my third violet over there. Do you understand? This is what he's saying, lah. This is what he's saying.
That's because there's significant overlap
between the second and the third again, right? In my picture, it's starting to overlap. In this case, it's clearly like the third spectrum is just inside the second spectrum, the second order, clearly. Correct or not?
Oh, because the angle is smaller than the
correct. So that means every other color, a lot of colors are of the third order is appearing before the second order even finishes.
Oh, okay.
So like obviously we already have a problem. We will not be able to tell the second or third order clearly. And that's not enough for a manual measurement. In a manual measurement, you actually want a few orders just to be sure.
All right.
So I hope this is clearing the topic at the same time, because diffraction grating, you faces multiple color in diffraction grating, because that's the purpose of diffraction grating. The purpose of diffraction grating is one of the things is to tell whether you are mixing colors or not, and to separate them again, obviously.
Okay, that makes sense.
Why do they want to do that? Because why do they want to separate color is it goes back to your. You haven't learned have you learned the absorption and emission spectrum?
That's in quantum physics, right?
Then it will appear very soon. They don't explain it that way, but they use diffraction grating to try to tell the spectra from the star, for example. Right.
Yes,
right. So later on, right? So if this makes sense, and you have no other question, let's move on.
Yeah. Okay.
That's so difficult to separate. Wow. Okay.
Is there any more?
Then I will ask you how to fix this. How to fix this problem?
My teacher gave. So that means I need to increase the angle, right?
You need to make the separation better. I don't think the idea is strictly to make the angle larger. You can actually make the angle smaller so they separate, right? You can also do that. But how do you do that? How do you do that?
Larger dive. What do you think? Larger diffraction grating.
Larger diffraction? I don't understand what larger diffraction grating means. What does that mean?
That means it's like here's like 500 lines per millimeter, right? So
okay, then you would have.
Do I need to have more or less than 500?
That's the main question. Yes, that's the main question. That's the main question.
So,
like you can infer from the formula. If you increase the number of lines, what will happen? If you decrease the number of lines, what will happen?
So I make this bigger, like say 1000, then
okay,
it'll be an even smaller number, right? So and increase and D will decrease. So if D decreases.
Good. Then,
if D decreases,
then referring to the other formula, yeah. So that contains the angle. Nice, yeah, nice.
So sine theta is n lambda over D. So sine theta will be greater. So yeah, So increase the 500.
So by increasing the number of lines, you're decreasing the D's, and you hope that the angle will be bigger. So I wouldn't say you want it to be bigger or something. I just say that you don't want an overlap between the second order and the third order. I just make it, because if the angle increases and yet the overlap happens, then you have the same problem.
So I need to decrease the angle.
No. If you decrease the angle and the overlap happen, also bad. So basically what you want to try to see is that, let me recalculate the maximum angle of the second order and then the minimum angle of the third, and see whether they are overlapping or reducing their overlap. You know what I mean? Just give it a try. Just give it a try. So just give it a try. Let's say you have 1,000 lines, right? You are going to do 1 and 2 again. Let's see what happens to the angle.
Give me a sec. Calculator.
Should be very clear. Yeah, should be very easy.
So part 1, 1,000, right? So 1 times 10 to the power -3 over 1,000. That number. How many numbers? How many ones is that? 1, 2, 3, 4, 5, 6. Equals to 2 times 650. So angle will be 1 times 10 to the power 6, -6. Math error.
I cannot see the calculator. Just tell me. Oh, right. I cannot see again. Sorry, now it's dark. Now it's too dark. This is math error. Wait. Oh, let me see again. Let me see again. Go. That's because, let me think. Wait, no, the top one. Oh, yeah. The top guy is bigger than the bottom guy. That's why it doesn't work.
Oh yeah, 650 times the power 9. So do I just wait?
I'm not sure what's happening, but obviously it's a math error.
Maybe I keep in all the. Sign to 650 and then. Do I just change the number?
Sorry, this is not supposed to be very difficult. Where? So your sine theta, right? Your sine theta is n lambda, right? N lambda d. What's going on here? Wait, I'm thinking for what's going on here. Let me see the bottom one. Sorry, let me see your bottom one. Is 1 to the power of -6, right?
Yeah, 1 to the power. 1 to the power, 1 times 10 to the power -6.
That one, sorry, yeah. Really?
1 times 10 to the power of -3 over 1,000 is.
Wow, that's bad.
I'll just try 750.
Wait, then how come you're 500? Let me think for a while. Because your 500 line per millimeter will result in
2 times 10 to the power -6.
And the 2 kinds of takes care of the problem. Oh, really? Wow. Okay, for now, try 1.5, that will solve the problem. So however, how many lines there is, it's just more than 500, but less than 1000. So just try 1.5 below. That will solve the problem.
So 750. Okay.
Yeah, it's not exactly 750, but yeah, just try 1.5. Doesn't matter, as long as it's more than 500. Right? You don't have to retype.
So 77.2 degrees.
Okay. That's the next to for 40.5, right?
So next one is 3.
3, and then times 350. This one should have no problem.
51.
I would say that the overlap is getting worse. Yeah, definitely.
Okay.
The overlap is getting worse.
That means I decrease.
So let's decrease quite strongly to like 100 lines per millimeter. So at the bottom, you just type 10, 10 times that.
10 times.
You're retyping everything, right? So just go up again. No, just go up. No, go up again. No, go up. No. The calculator. Show me the calculator. Press the arrow up, up again. Whatever the answer is, right? So you go to the answer. It was just type 10 to the power of -5, right? No. I mean, change it to -6 now. Yeah, okay, right. No. And then the front one change to 10, please.
Oh, here change the 10 in front of the side verse.
Because 2 is supposed to be 500. Yeah, correct. Change. No. When it's 500, 2 times 10 to the power of -6, right? Correct?
Yeah.
Okay, then change the 2 to 10.
Wait, 2 times, is it 650?
Look, yeah, stop there and change to 10. No. Yes, stop there. Thank you. Yes, please do this. Okay, this means that this is like around 100 lines per millimeter. So now we are reducing the number of lines, right? 7.46.
7.46 degrees.
Okay, let's see what happened. Let's see. Yeah, so let's see what happened with 3.
3 and
times 3. Okay, let's see what happened.
Yep, 6.03.
Yeah, even though it looks like it's getting smaller, but it looks like it's getting smaller, but there is still an overlap, and we can't really tell which overlap is better and which overlap is worse. We can't tell. Right? So I guess that's why they don't ask this. So right now we don't know which one's better, 77 and 51 or 7.5 and 6.02. Doesn't matter. As long as you can explain the problem, it's good enough for now. Okay, next question, maybe the last one.
Yeah, let me look for more questions. There was, oh boy. No, that was on, oh man, that was on the slides. How do I, it's,
Maybe you can put it in the Jamboard.
no, it was like my teacher put it up as like extension question, but you know, just sort of went through it and like, all right.
What do you want to show me? Yeah, what do you want to show me?
I can't really show it to you. I can only describe it, I guess.
You don't have it in your screen right now?
No, it's like it was on the teacher screen, so I didn't take a picture of it.
Okay,
like,
fine.
Okay. It was
let's try.
It was like a diffraction grating, and then there was all the fringes, right? He said, what happens if he tilts the diffraction grating? Then how would the fringes change?
That means you have a source, right? I suppose you have a source. Sorry, and then the grating is original like that, and then tell it like that, right? The screen still stays, I suppose. The screen still stays. Right? It's a grating.
Yeah.
So I'm in page 5, right? Yeah, I'm in page 5.
Yeah, so the grating is horizontal, then he tilted it like up on the.
You mean vertical,
like
is it?
About,
You mean
about the
vertical?
vertical axis. Yeah.
Yeah. Okay. So it goes like that, right? Okay. Then your question is, what happened or what?
What happens to the fringes? Like, do they get further apart? What about their brightness? And like, that was part of it.
This is out of syllabus though. So your teacher talks about it because it's important, or it's just for fun?
Oh, because it appeared in a question. It appeared in a prelim question.
No, this is out of syllabus.
Really?
Yeah, no, you don't need to know. I really mean it. You don't need to know. It appears in a prelim question. Okay, it's a prelim question of maybe let's say a RI. So no, don't need to know.
Oh, okay.
It's more important to learn the other basics first. Like it's not that we're ahead here. Like it's more important to learn about the resolution if you don't understand resolution. For example, I would rather you ask those questions, not this one. Okay.
Yeah, okay.
Other questions, please?
Not really.
Not okay, right?
There wasn't much. Okay. This one.
Show it nicely. Yeah, show it nicely.
It's a multiple choice question.
Zoom out a bit, please.
I'll just show you the context first. This is the context.
All right, zoom out a bit.
Yeah.
Okay, got it. I'm moving to the next page of Jamboard, and then what do you want to show me?
These are the options.
Okay, nice. I like it.
Let me just give there we go.
Okay.
So the ABC,
slit.
There's E as well.
Right. Okay. Right. So when the slit width is smaller, right? Smaller. Again, according to physics, you will expect what changes would you expect? Right?
Intensity to decrease, right? I expect that.
I suppose because the split is smaller, I suppose that makes sense, right? But if that's all, then you're missing this chapter. Is there anything else that you would expect?
Something about the separation, but
I was really hoping that you will say, in this basic, the diffraction gets worse, which is what you kind of say just now. Like the diffraction becomes bigger, right?
Yeah, I guess.
Wouldn't you expect that? At least, wouldn't you expect that?
If the width got smaller.
Like it's a smaller hole, right? Like when I say the diffraction should be worse, like bigger. If bigger diffraction means actually a bad thing. Usually it's not a good thing, usually.
Because they start overlapping?
No, there's no overlap in the double slit.
This is double slit. I thought it was separate.
This is a single slit even more. Just one pure wavelength somewhere. If there's one pure wavelength, then there isn't overlaps. There isn't overlaps. If that makes sense.
It's like I need to review that.
Wait, why are you treating this as something new? So for example, where I say, so fine. So here's B Okay. B answers your question So B totally answers your question. Like this thing, the diffraction pattern of a slit narrower than A. So clearly answers your question right? The intensity drops and the so to say the diffraction gets worse
It gets bigger.
Yeah, which in most cases always means it's worse because a smaller thing appears bigger, not in a good way. It gets blurrier basically.
It appears further apart, like the bright fringes.
Yeah, the bright features appears the bright and the dark, whatever fringes it appears further apart, and now the intensity is lower. So I suppose bigger may mean that it is easier to see. That we may think like that. That's not true. That's not the total. That's not the net effect. The lower intensity makes it harder to see. Okay. So, but it's as if when I say, oh, it's a narrower slit, so the diffraction should get worse. It's almost as if it's something new to you. Is it new? Like I'm not saying that you refer to your nose. No, I mean, I thought you understand that narrower slit, worse diffraction. I thought you know that. No, man?
I mean, if I think of it in terms of formula, which is what my teacher told me, then yeah, I guess. Yeah,
Okay.
I guess.
Then visually,
Yeah, I
then
guess
we
it'll
go.
be.
I really hope that
Yeah.
it's not just formula. I really hope like it's not that. So you go to the wave thingy that we talk about, the wave thingy, the wave and the wave front in the lecture note, right? The one that asked your teacher, asked you to ask your teacher, right?
Okay, that's what I was.
So the first thing to note here, see, a bigger obstacle or a bigger gap will have less diffraction, so to speak, right? But when something is comparable or smaller than the big one, then you will get more diffraction, correct? So it goes to show if you narrow it even further, you will get even more diffraction. First thing first.
Okay.
Okay, so now I'm going to explain to you again, because this is abstract. We don't see this effect too much. I'm going to explain to you why more diffraction means the thing is bigger, right? The separation, the fringe separation is more. So actually seeing something bigger, so to speak, even though dimmer, but bigger. I'm going to explain why that's bad. That's better. So let me show you again. I'm going to have to pick up a picture first because I notice your note may not have that. Yeah. Okay. Sorry, very slow. Come on, show me something nice. For goodness sake, why are you not showing me something? Okay, never mind. Would you go to the resolution note so that I can explain why bigger is worse lah?
Sure.
The one with overlapping. Yeah, this one, right? So this is still one slit, but you have now two objects, right? So so I'm trying to draw something, right? So by copying this. Remember, I was explaining to you, single slit is very practical because, for example, that's how our eye works. Or, for example, that's how microscope works. It's a single slit device. It's not a double slit device. Our eye doesn't work that way, even though we have two eyes. It doesn't mean that it's double slit because we have different retina for both eyes, right? So our eyes actually see things slightly differently. Now, if the slit is narrower, right? Here, I just narrow it down the slits. The S2 will appear bigger, right? Will appear bigger. And dimmer also, sorry. So bigger and dimmer. Okay. Bigger and dimmer. Again, if it is one object, good lah, it's bigger, even though it's dimmer. Fine. At least I know something is there. Can you accept that this bigger, again, is advantageous for us to know that something is there, but it is already disadvantageous in knowing exactly what it is, in the sense that this is totally not sharp. The real
like
object is this
distinguishing,
small. Like even the detail of the object, it's not helpful at all. Because this small thing gets blown up in a very unfocused way. In a very unfocused way. I gotta show you a picture of this. I really gotta show you a picture of this. It just makes sense. Show me something. This is the best. This is the best. Okay, I put a picture. Now you know what bouquet means, right?
Yeah, the flowers.
No, bouquets are not the flower. No, that's the bouquet. No, I don't mean bouquet. I mean bouquet as in the modern handphones can make the background blurry kind of thing.
Oh, yeah, I guess.
Yeah, the term for that is bouquet.
Oh.
Okay. Here's a nice picture of some flowers. Some are in focus. The one in front are not, right? The one in front are not. And the one behind are even worse. We don't even know what those things are. We just know that they are not in focus. And so our eyes are focusing on certain fewer things, which maybe makes the picture better, I suppose, right? Now, this is not bokeh. I'm not saying that bokeh is diffraction. But what I'm saying is this small thing become this big thing in a very unfocused way is very similar to bokeh. You can't tell what this thing is what. It's just a big, the blurry thing. Yeah. Actually, I don't know. Is that a pattern? Is that a light? Is that twinkle, twinkle, little star? I don't know. And artistically, that's the point. I don't want to know. It's a nice background, blurry. I can still focus my eyes on the flower. I suppose that's the point of this picture. It's not a very well taken picture, but the background blur is not a problem from an artistic point of view. It's a problem if you're trying to find out what that blurry thing is. Okay? If you're not interested in the flower, but this background. Now in when you're viewing some small thing through your eye or through your microscope, this small thing, instead of saying small, becomes something big and blurry. Not helpful at all in terms of telling what that thing is. And this thing, for all you know, could have been two things, but very close to each other. It could have been these two small lights here. Can you see the lights? It's very small, two small lights. But since the small are getting blown out of proportion, they appear as one big light. Not helpful.
It looks like one big thing.
Yeah. Again, which is again blurry, no detail at all. Cannot tell. Okay. I'm using bokeh as an example, even though diffraction is not bokeh, but the net effect is something like that, something like that. Something like that. So it's not helpful when you're trying to observe a bacteria. I'd rather the bacteria be small, but detailed. At least I know roughly what it looks like. In this case, it's not helpful at all. Like what am I supposed to be seeing here? Something like that. Okay. Now, this is what it means when it is more diffracted. In general, it is worse, not better, even though it is getting bigger. Even though. Can you accept that?
Sure, I think so. Yeah.
Right. So this is, why are we talking about this? Because back to the, sorry, there's a context, right? Why are we talking about this? Because the question you asked. So first thing first, if you notice the slit is getting narrower, it's not a good thing at all because the diffraction is bigger. I just don't want you to have a clash of logic. Aren't bigger supposed to be better? Nope, in this case, because it is unfocused. They don't tell you that story in the lecture notes. As far as I can tell, they don't tell you this. That's why there can be a logical conflict, but there isn't a logical conflict. Bigger is worse for diffraction. Narrower slit is always worse for a for this kind of purposes. Always works in terms of viewing. Okay.
All right. Okay.
So in the questions leading to this single slit, you will see our eye, very rare. You will see microscope, quite common, and you will see telescope, very common. Right? You will see that the telescope, people try to make telescope as big as possible. Not always practically possible, right? But now you kind of can sympathize why we want to make such a big telescope. Because the size of the telescope is the size of the slit width. So to speak, the bigger, the better. Okay. If your eye could be bigger, it would be better for your viewing purposes. It's just that we will look ugly. Okay. But what we see will appear better for us. Again, will look uglier. So I suppose there's a limitation there. Something like that. Okay.
Okay.
So back to the question, do you know why D is the answer now?
Because the slit width is narrower.
So the reflection is worse, so to speak.
So it's bigger apart, further apart. Is it correct to say further apart or just bigger?
Both the same, like the fringe separation is bigger, right? So the fringe are further apart, right? Which is not a good thing. Again, it's not a good thing. It's a blurry kind of thing. It's not good.
Yeah, so it gets further apart. It does the intensity decrease.
And the intensity also drops.
Also decrease.
Because that's just because the smaller the width, less light you let in. That also makes sense, no? I suppose. Where it does it drop to over 2 or over 4, they don't tell you immediately, right? We can work out the formula, but at least this one drops, so we choose this one. So in that sense, the answer is not A, the answer is not A, and definitely not B and C. Definitely not. Okay. Now, did that answer your question?
Yeah, I did.
Yeah, I hope it will help you with the questions further, because I haven't seen any resolution question. This is only a single slit, not single slit resolution. Not yet.
Some of the resolution questions are kind of like just apply formula.
True.
So I guess which one?
Until they give you a rather more complicated question and you are supposed to understand the question, then maybe that will give you some problem. Maybe.
Yeah, definitely.
Later on, no problem. Right. Okay, any other question?
No, that's it.
Okay, I'll see you on Thursday.
Yeah.
Right. We'll try to, let's hope that on Thursday, we'll try to move forward a bit on the chapters, like for example, the binomial, hopefully you can understand more. And then on Sunday, we can answer your tutorial questions. Okay. Now, you still haven't sent me the pictures though.
Yeah, I'll get it now. I said,
Okay.
Sorry.
Okay. I'll see you on Thursday then.
Yeah.
Bye.
Bye-bye.